Hello and welcome. My name is Mary Napolitano. I'm a medical physicist and product manager here at Standard Imaging. Today's webinar is entitled Be Confident in Plan Delivery. So let's go over a bit of housekeeping before we get started. Today's webinar will be recorded. Please enter questions at any time during the presentation in the GoToMeeting dialog box. I will answer all questions at the end of the presentation. Standard Imaging is based in Middleton, Wisconsin, and was founded in 1989. At Standard Imaging, we design and manufacture a full suite of QA products. So during my presentation, I will begin with a short discussion about Plan QA, sharing some thoughts from a special AAPM meeting on IMTQA. One of at least my takeaways from the meeting was that log file analysis is a nice tool to add to your QA toolkit. And I fully understand that I have some bias, but it's a really interesting tool provided by your LINAC with lots of great information that you can utilize for QA. I'll overview the basic workflow of Linance View, and I'll provide a bit of background on log files and how and why they are useful in increasing your confidence in plan delivery. I'll go into some detail on log files and control points in plan files. In particular, the fluence comparison is useful when alert criteria for pass-fail are based on gamma calculation criteria. I'll suggest some examples of specific plan fluence analysis. As perhaps you joined because of your interest in being confident in your plan delivery, I wanted to share some thoughts from a really nice conference that I attended last week. The AAPM sponsored a virtual special meeting on IMTQA. And while there were many takeaways, I'll share just a few. As you see the Swiss cheese here, this analogy was made several times during the conference in reference to QA methods, being like slices of Swiss cheese, that all slices have some holes, so all QA methods have some holes, so we need to combine QA methods to ensure that failures are caught by QA and then get through the Swiss cheese to the patient. And so my diagram isn't quite as good, but you can envision multiple slices of Swiss cheese and the holes. And so you need to have a nice QA setup. I've provided, just in case you're interested, this is the link to the conference, which you can get to on the website, of course. And the question then is, should AAPM or some other group provide an alternative to our current pretreatment QA? At least in the US, it's quite common and is the most traditional method for pretreatment QA, use of a detector array for that measurement. But what is needed is a real test that is actually sensitive to finding the problems. And there's some conversation I'll share with you about the sensitivity of finding these issues with QA tools on the next slide. And then some additional tools for QA were proposed. So where exactly are the risks in the workflow that we need to be looking further into, and where should we focus? So I know a lot of time and energy and physics resources and budget are put into some of these detector arrays, but are they really catching the QA, doing the QA and catching the problems, the real problems in the plans. So particularly interesting was an update from IROC Houston about their phantom pass rates, and I wanted to share it as presented at the conference. While this data compares much historical information, there are still relatively low pass rates, even if you look at just the past couple years worth of phantom irradiations. And please note that there are still relatively low pass rates, even with these looser criteria than are typically used for pretreatment QA at clinics. And so, for example, using a gamma of 7%, 4 millimeters, only 88% of the head and neck phantoms that have been sent out from IROC Houston, irradiated, sent back and analyzed, have passed the test. And then just in addition, the clinics send in information, including their QA, and there is shown to be a lack of correlation between pretreatment QA pass-fail and IROC phantom irradiation pass-fail. And so further in the conference, other presenters suggested that in vivo QA tools should be considered, items such as EPID analysis, log file analysis, and transmission detectors. So with that short intro, I'll transition into log file usage techniques with Linance View. So here's the basic information flow for Linance View. Everything, of course, begins with the RT plan, export, of course, over to the Linance View computer, as well as through to the Linance console. And then as each plan is delivered, you could, of course, deliver before patient treatment or pre-treatment QA, and the log files would be picked up and analyzed, or just beginning with your first treatment fraction. And so once the delivery occurs, log files are automatically synced into Linance View. The analysis occurs as it's syncing, and then we can analyze in Linance View. In addition, once the analysis occurs, one can have an option to automatically generate an RT plan from those log files, so that you can optionally, as a method to review further if you have a failure, for example, you might want to investigate further and re-import that plan as delivered by the Linance back into your treatment planning system, for example, or other external third-party software for 3D dose computation. And this is something that one can do just if one wants to investigate further or work it into an automated workflow. So with that, let's further discuss log files. So log files were initially generated, as a Linance feedback mechanism, designed right into Linance. The MU, positioning of each MLC, JAWS, gantry collimator are all recorded. And these, are actually measured parameters by which the Linance operates. And, when the parameter, for whatever reason, exceeds tolerances as designed, beam off would occur if it exceeds tolerances. And there's a feedback mechanism going on throughout as the plan is delivered. So what we're really interested in collecting are these log files during all delivery and analyzing them. So the different Linance have different formats of log files. The sampling rate is the number of data records per second, and varies for the different types of log files. The older variant Linance series sampled at 20 records per second, and saves Dynalog files. The Varian TrueBeam samples at 50 records per second. Electa provides some slightly different recording options. Their TRF files generate 25 records per second, but those cannot be accessed in real time by external vendors. So alternatively, for Electa, we need to access via the ICOM-VX interface, which was created specifically for external vendors. The sampling time there is 4 records per second, and that's what we use in Linance View to allow for a fully automated system. So log files can be used to make direct comparisons of multiple parameters, such as the job parameters, carriage positions, MLC leaf position, gantry collimator angles, etc. And so as a clinical physicist, something like multiple small leaf misalignments, can be difficult to understand and determine clinical relevance. But in order to provide this link, one can directly calculate the delivered fluence in order to provide the link between the RT plan and the log files for analysis, and that's what we do. And so I thought it might be educational. Hopefully you will agree to bring up and provide and show you the information inside these log files. So this is a display of a Dynalog file. These slides are from one of my prior colleagues, and I thought they were pretty good, so I'm picking them up and reusing them. So you can see labeled along the top the meaning of the parameters in each column, things that are familiar, gantry angle, collimator angle, your X and Y jaw positions, carriage, leaf expected positions, etc. And then here along the left column is the current dose fraction, which is mapped from 1 to 25,000. And note there's no explicit mapping to the control points. So what we have to do in Dynalog files is the prescription is 150 monitor units. And so for this particular configuration, specifically where the gantry angle is, the leaf positions, we just go ahead, multiply by the 2198, which is the current dose fraction, divided by the 25,000 and get 13.2 monitor units. So that's the way we map to the plan. And again, the parameters are logged here every 50 milliseconds. Next is a trajectory log file. This type of log file is much easier to map to the RT plan control point because there's a direct fractional MU, as you can see here, as well as control points. And again, all those same parameters, the jaw positions, leaf positions, gantry rotation, etc. And this data is specified every 20 milliseconds. So then how do we compare this into the RT plan? I'm thinking perhaps you've opened up and reviewed RT plan before, but if not, here's just a quick view inside of a RT plan. This is for control point 1, as you can see here specified, and all those same parameters, X jaw, your X1, Y1, Y jaw, Y1, Y2, MLC positions, gantry angle, 181 degrees, collimator, house, and then we have the fractional MU. This is control point 0, so of course we're starting at 0, and it's specified as a cumulative meter set weight. And then to just look further on in the same plan file, these screenshots show control points 88, 89, and 178. And of course, you can see we start with a gantry angle 358.98 with this cumulative meter set of 0.49. And then by 0.502, the gantry has moved to 1 degree, just over 1 degree. And you can see that fractional MU increase, and then here with the last control point is at the end of plan, of course, your cumulative meter set weight of 1. So once one understands the information coming from the log files, the next step is to be able to map the log file records to the RT plan control points. And this is where Linance View comes in. After or as the mapping is done, the analysis takes place. The fluence calculation is performed based on the RT plan and the measured parameters collected during delivery by the Linance as listed in the log file from measurements in the Linance control system. The 2D fluence can be analyzed using the traditional gamma analysis between the planned and delivered treatment. The RT plan specifies those delivery points, delivery based on control points. And I want you to note and perhaps think about, if you haven't, that only at these control points is the configuration specified. And between the control points in the treatment plan, the leaf movement and monitor unit is not specifically defined. One assumes linear motion between the control points, but only at the control points must the conditions be within tolerance for the delivery to occur. And this direct analysis is highly sensitive to catching errors. So moving on, in order to allow for automatic analysis, doing all this matching, one sets up templates to provide automatic notifications. All the parameters are analyzed all the time, but only reports and alerts are generated via audible alerts or email alerts when the custom templates parameters are beyond the limits specified for the individual limit. And of course, these alerts can be based on specific parameter tolerances, jaws, and the entry collimator table positions, or of course the fluence map comparisons. And we do allow comparison using gamma, chi, or delta. And I just wanted to again point out that I've been hearing physicists discussing issues with use of gamma, particularly for plans that have high dose gradients. And so we do have chi and delta as an option if you are not a fan of gamma. Plan complexity is another great item to review. And if you haven't looked into plan complexity, I can send you some references. Just reach out. Linance View provides the modulation complexity score, so how complex your plan is based on the leaf sequence variability and aperture area variability. And so a plan complexity score may assist you in determining which plans you would like to QA using additional tools such as a detector array. And so, looking at QA as a nice overview and what tools do you have available. And, one system can aid another one. So once your system is configured and custom templates set up, log files are just sent automatically, continuously as patients are delivered on your different Linux through Linance View. Each fraction is tracked, but alerts are only generated when your clinic-specific rules are exceeded. Either audible alert or email alert can occur. And I'll demo this just very briefly to make sure you understand what I'm talking about. I think I have a window up I need to move. There we go. And so I hope you can see it now. This is a Linance View. We're now version 3.12. This is about ready to be released. And this is just a basic dashboard like you might have up in dosimetry or in the treatment console area. And I went ahead and submitted 6 days worth of sessions. So this is one plan, the same plan delivered on 6 subsequent days. And the plan has one arc, although it's named ARC 2. And so what I'll go ahead and do is I'll send a second plan in. The second plan I'm going to send in is an electa plan. It's 3 days worth of sessions. It's a single ARC plan, and it has a relatively high modulation complexity score, 0.403. And so the probability of passing, it's a good solid plan. And so you can see that all 3 sessions that I just passed in have already synced to the log file, was analyzed, and you have you can see your passing criteria here. And one can hover over to look and see that there was 100% monitor unit comparison, 97.3% gamma pass rate. If you didn't catch that, my apologies. I just hover over and you can go and look. Everything that's failing is in red, and it shows your criteria. Your alert and fail criteria are to the right, and then the actual parameters are to the left. So this is, not the full software. This is just a dashboard, and I'm logged in as a basic user without a lot of rights. The physicist, of course, could go in and see more details, and I'll show you that later. So I think I will go ahead and pick a failing or at least an alert plan to put in, so you can see what that would look like. So I've selected a true beam since I sent a couple of electives in. This is a single ARC session.
Alert. Alert.
And you could hear the alert. I guess you can hear that through the audio because it's coming through my computer audio, but you heard the alert, I hope. This plan had a modulation complexity score of 0.821. And you can see the alert shows up. Typically, we keep it sorted such that the alerts or failures are maintained at the top of the list. And you can see as I hover over that it was a monitor unit difference that caused this failure. Another thing to point out that I can't recall if I pointed out previously is this particular LINAC does not have the automatic RT plans being exported, whereas the others did. So there was just an analysis. And you can see, I think, I'm not sure if it shows through, but I just got an email alert as well. And so you can see that I received the same information that one could hover over. If I was a physicist, I would have received that same email alert. I didn't have the PDF report attached. You can choose to have a detailed PDF report attached to the email as well. So you don't even have to walk over and log in as a higher level user to review the issue. As well, this particular plan has a tag so that it doesn't use the default template. It's using a specific template for static plans because this was a, let's see, what was this plan that I sent in? I don't have it noted, but it is a static plan. So with that, I'll continue on a bit through the slides just to keep things moving. So I showed you the basic dashboard, which would be open in the treatment room or dosimetry. And now I'm going to transition into some sample fluence comparisons. Should you want to review even your passing plans, you can go into the software or look at PDF reports. If you select to have those automatically sent even for passing, that's probably too much email, so you would probably not want to do that. You go and review, and you can see within the software, these are some screenshots the Archie Plan Fluence Map, the Log File Fluence Map. You can go in and look at your gamma pass rate histogram. This one is a 99.7% pass rate at 2% 2 millimeter with a cutoff of 5%. The fluence maps are created by projecting MU-weighted segments to the isocenter plane. And since the values did not exceed thresholds for alerts, no action is required for this session. Another case of 3R express plan delivered on TrueBeam. Similarly to the previous case, the fluence map comparison shows 100% pass rate for a gamma of 2% 2 millimeter and 5% threshold. And as long as you have a well-commissioned system and keep up with your machine QA, the vast majority of your plans will not generate any sort of alert. One gets confirmation as each session is delivered, and then a summary report is generated when the treatment ends. In general, good results are not surprising as there's no setup uncertainty, no finite space detector grids, but we do perform QA in order to catch problematic plans or delivery sessions. So here's just an example of a failing plan. This failure, well, I'll just say that this is a complex plan, modulation complexity score of 0.074. It showed both as a fluence failure and a leaf failure, both in the RMS error and maximum deviation of alert. So you can see the RMS errors. The red line is the failure line, and you can see a good portion of leaf pairs have their RMS error above this failure as well. You can see this is specifically leaf pair number 10, and for both banks A and B, and the red lines show the plus or minus failure limits, and the orangish lines the alert. And so you do have the tools to go in and take a look deeper into your fluence map and your MLC leaf positions, anti-pollinator, etc. But that is outlined for you as well in the dashboard, or you can look at the graphics. You can actually play your plan as well. Let's see, moving on. What else did I need to say about this? Yeah, it was a failure of 88.5% for the fluence map, 2% 2 millimeter, 5% threshold. Notice that's in red. We also have the mean gamma. It failed on the mean gamma as well. And I did want to point out that the software is only opened and reviewed to allow for further investigation. And if you'd like to see a more in-depth software demo, I'm happy to do that. Please don't hesitate to reach out. So with that, I'm running close to my 30-minute limit, and in summary, I'll just go ahead and close. So close to real-time log file monitoring for every patient can be performed with Linance View without impact on patient workflow. Therapists can see dashboard results within seconds of treatment completion, and Linance View can provide confidence in your plan delivery. So then, thank you for your time and attention. That concludes my presentation. Please type any questions into the dialog box, and I will do my best to answer your questions. So I'll give you a few minutes to type because I don't see any questions yet. And if I don't get any questions, we'll go ahead and close the session down. But feel free to go ahead and reach out to me if you have additional questions later. And as I don't see any questions coming in, I'll go ahead and close the session. You can contact me via your sales representative, and you can find that information on the Standard Imaging website. So thanks and have a great day.